Hi everyone, so now we have a question from chapter 9 in physics. Problem number is 9.74 and it says, a sphere consists of a solid wooden ball of a uniform density of 800 kilograms per meter cubed and a radius of 0.3 meters, and it's covered with a thin coating of lead foil with an area density of 20 kilograms per meter square. Calculate the moment of inertia of this sphere about an axis passing through its center. So now, as we read the question, there's two types of moment of inertia. So the moment of inertia is going to be equal to I solid sphere plus the moment of inertia of the hollow sphere. So the solid sphere is the solid wooden ball, and the hollow sphere is the coating of the lead foil. So now, on the side, I put the equation for the solid sphere and the equation for the hollow sphere. So let's copy them down here. So it's going to be 2 over 5 meters mr squared plus 2 over 3 mr squared. So the m right here is, let's make that as W for wood, and right here F for foil. So now we have two different types of M. So as we know that the density equals mass over volume. So for the first part, we can calculate the mass by this equation. So by isolating the mass, it's going to be M equals to the density times the volume. So let's write it right here. So 2 over 5, the density, which is noted like this, times the volume. So now we need to know the volume equation. So the volume equation is going to be 4 over 3 pi r cubed. So we're going to write it 4 over 3 pi r cubed. So we're going to multiply this whole thing by what we have here. It's r squared. Okay, so now that's for the first part. For the second part, we're going to have 2 over 3. Okay, so the mass right now, it's an area. So the mass equals the area density times its area. Okay, so the area density, we're going to note it as sigma. And for the area, it's going to be 4 pi r squared. 4 pi r squared. And all this times the r that we have right here, which is squared. Okay, now let's try and simplifying this equation so it would be easier to handle. So multiplying the numbers, multiplying the exponents to have one exponent. So it's going to be a over 15 pi r to the 5 plus we're going to have a over 3 sigma pi r to the 4th. Okay, now we have similarities between pi and r and the number a over 3. So we can take that as a common factor. So we're going to have a over 3 pi r to the 4th. So that's a common. So we multiply this with what we have. We have the volume density, and we have the number right here. So we have it divided by 5 r multiplied by r plus. So all this cancels out and goes to the other side, and the only thing we have here is the area density. So this is going to equal. We plug in the numbers, a over 3 pi. So for the r to the 4th, we're given the radius, which is 0.3 to the 4th, and multiply this whole thing by we have the density, the density which is 800, multiply it by the radius, 0.3, divide that by 5, and adding to that the area density, which is 20. So calculating this number, so this is going to give us, so the moment of inertia for the whole thing is going to give us 4.61 kilograms per meter squared. So this is how you find the moment of inertia. By splitting the moment of inertia that you have, calculate it and get, taking the common factor and plugging in the numbers, and you get this as a result. Thank you.